So next question, 9. Yeah, can you read it, Navid? Question number
Yes,
9.
sir. An unstretched rubber cord is stretched by a force. The force F is plotted against the extension X. F is slowly increased from 0, causing the cord to extend along the path P. F is then reduced back to 0 along path Q.
What is represented by the shaded area? Okay, so it's going from 0 through P, then returning back to 0 through Q. Okay, then we are
Yes,
getting
sir.
the shaded part. What this shaded part is representing, you have to find. First, we are extending the cord, then it's returning back to original position again, through path Q. So, what is shaded area showing you?
Sir, X is extension, right?
Yes, yes, yes. X is extension. And in
So
deformation,
force by extension.
yeah, you got in your in deformation notes there is one formula, there is fx, right?
Yes, sir.
So that,
K is equals to Fx.
yeah, k equals fx. So uh, not k equals that one is uh, another formula like half fx, right? You got any formula like that over there? Hmm? In deformation, work done, the formula of work done, I'm showing you. Did you go through the notes, Navid?
Sir, I went to the notes. Yeah,
Yeah, you should
the
learn them.
first the
Listen,
first time we. Yes, sir.
listen, please, my dear. If you don't learn them, at least you should learn the formula definition, these things, okay?
Okay, sir.
Otherwise, you cannot recall what is necessary for each of the questions. Uh, you should learn them. All the
Yes, sir.
formulas, all the at least contents, those you should go through again and again. At least before the class starts, you have a look
Okay, sir.
for once, or you before try the worksheet that you go through the notes. That will make you more easily get the ideas. Okay, to solve the question. Otherwise, it will take time. You are now in a position that your back is uh, touching the wall, right? Isn't it?
Yes, sir.
So
অবশ্যই।
you have to move forward now. This is worksheet. We are going to notes, deformation notes. There is one formula, half kx square. Another one is half fx. Okay, for work done in you see, this one is ke. That one you learned in O level. You see strain energy. Work done equals half fe or half fx. Okay, is it clear? This formula you have to learn. Work done. The extension force multiplied, that is coming work done. And work done also half k x square. Okay, both. Okay, both this formula you learn, memorize. So strain energy graph, you see the area under the graph is giving you the work done. Okay, isn't it?
Yes, sir.
Hello, Navid.
Yes, sir.
So you see the diagram given here. They are saying to go through this path, you have stressed, right? Extend, huh?
Yes, sir.
Yeah, extension. There is, if you are pulling anything, stretching anything, that time there is work done. Then it's returning back with this path. So uh, area under the graph you take, you'll see the area under this P, the line P, we are getting area under it is bigger, right? So there is more work done. Then area under Q, there is less work done, isn't it? So, Abid, Asan,
Yes, sir.
so you are having more work done for P and less work done for Q. Then in between some work done, you see there is a gap, right? Isn't it? So,
Yes, sir.
where this work done or where this energy is lost?
Sir, as probably
Yeah.
heat.
Yes, the energy dissipated as heat. So this is coming automatically now, right? When you got the explanation, now your brain is working, right? Isn't it? The way
Yes, sir.
you got the
Yes, sir.
information, the way you got the explanation, now your brain is working. Yes, there might be there might be energy loss by heat. So the answer is C. Okay,
Yes, sir.
is it clear?
Yes, sir.
Okay, now this one is very
Lost.
simple. You got this formula 10, the momentum one we discussed, right? Read it, huh? Asan, read it.
A rigid circular disk of radius r has its center at x. A number of forces of equal magnitude F at the edge of the disk. All the forces are in the plane of the disk. Which arrangement of forces provides a total moment of magnitude 2Fr about x?
Yeah. So, which one? Your radius is r. Then you got the
A,
formula,
sir.
right? A, yes, correct. It's very simple. This is the, this type of easy question does not come in AS. It's the easiest, one of the easiest question in AS. Okay,
Yes, sir.
very
Yes, sir.
simple. Another simple question, 11. It's O-level concept only. Yeah, yeah. Farhan, you read. Farhan, you read it. You can do it.
Yes,
Farhan.
sir. The diagram shows a uniform beam PQ. The length of the beam is 3 meter and its weight is 50 Newton.
Mhm.
The beam is supported on a pivot 1 meter from end P. A load of weight W is hung from end P. The beam is in equilibrium. What is the value of W?
Hmm. So it's just O-level concept. You can do it easily. Very simple. Think of how to do it. What is the conditions for equilibrium? Clockwise moment and anti-clockwise moment should be equal, right?
Yes, sir.
So your anti-clockwise moment you got, that is for the weight W, and the uh, clockwise moment you have the weight of the beam, right?
Yes, sir.
What is the weight of the beam given?
50 Newton
50 Newton. Where it will work this weight? Where it will work?
on the pivot.
Not on the pivot. It will work in the middle, in the center of the beam.
Okay.
Or because it is uniform object, right? Any uniform object, the center of mass in the middle, and the total weight will work in the center of mass, right, or center of gravity. Is it clear? So the middle of the ruler beam you have to find, right? Where it is? Here, right?
Yeah.
Isn't it? It's here, right?
Yes, sir.
So this 50 Newton will be here and it's clockwise moment, right?
Yes, sir.
So you got here a clockwise moment source, that is 50 Newton force, and we should do the working from the pivot always. 50 Newton is from pivot zero point 0.5 meter, right?
Okay.
Isn't it? Because the whole
Yes,
beam
sir.
is 3 meter, the middle is 1.5, and from the pivot it comes 0.5, isn't it?
Yes.
So from here to here, we are getting 0.5, right? Exactly 0.5. Okay,
Yes, sir.
is it clear? So you can do now clockwise movement equals anti-clockwise movement formula, you know, F1 D1 equals F2 D2, right?
Yes.
You can remember that, right? So your F1 is W, the one you have to find. D1 is 1 meter, then equals your F2 is 50, then D2 is 0.5, right?
Yes, sir.
Then what is the value of W? Check. It's only 25, right?
5. Yes,
Yes,
sir.
sir.
25 minutes. So it's only your O-level concept, right? Was
Yes,
it
sir.
very difficult?
No, no.
No,
It's a
sir.
very simple thing, right?
25. A answer.
Yeah, A is the answer. So do you think Snap will help you to get the notes in the group? You have
Yes,
a
sir.
Snap and send it to group, then it will be better. It will be preserved over there. Yeah, then 12. You try 12 also now. 12 is also done. In topic 1, we did it in vector analysis. That one we had, you see, we did horizontal component, vertical component. That idea should be used here.
Okay.
Very simple. In structure, we did a similar question, right? Navid,
Yes, sir.
topic 1. So, so are you understanding what to do? Yeah, Hassan, can you read please question number 12?
In a high wire circus act, a man of mass 85 kg is standing at rest at the midpoint of the wire. The wire on either side of the man is at angle of 20 degree to the horizontal. What is the tension T in the wire?
Okay, so how to do it? The person's weight is 850, like the weight will be 85 multiplied by 9.81, right?
Yeah.
Hello. So
Yes,
what
sir.
is his weight? Take what is his weight?
Weight is 850.
No, no. You are not in O level now. You multiply with
Oh,
9.81. Okay.
yes, sir.
So his weight is
833.85.
working here. 834 we can say, right? We can say 834. Okay.
Yes, sir.
34 Newton. Okay. Now, in this position, it is in equilibrium, right? Isn't it?
Yes, sir.
So, there is, the weight is working downwards, and there is also one resultant force. You see, these two forces are working, right? Tension force, these two are working, and they have, according to parallelogram rule, there should be one resultant force here working upwards, right? Isn't it? Hello, are you understanding what I'm saying?
Yes, sir.
So that resultant force is balanced with this weight, isn't it? That's why it is in equilibrium. And we can say the resultant force from this two force T is balanced here. 834 Newton is working here, right? 834 Newton, isn't it? Hello.
Yes, sir.
So here we are having 834 Newton. That is coming from for both the tension force, isn't it? Now, if you think this is a triangle, right? This one is a triangle, and this is another triangle. So for each of the tension force, if you think separately, half of the 834 Newton is working. Like for the left side, uh, half, and the right side half is working, isn't it? Is it clear? Hello,
Yes, sir.
are you understanding what I'm saying?
Yes, sir.
Navid, have you
Yes,
understood?
sir.
So what is the half of 834?
It's 834
Oh,
divided
834
by
half.
2, 417.
417.
400.
17.
So you write here for each of them, we are having 400 divided by 2. So we are having for both of them 400. Say again, 417
17.
newtons. Okay, that means now we can deal with any of the triangle, left side or right side. You know Pythagoras formula, right? And you know the
Yes, sir.
trigonometric formula sine theta, right? Isn't it? So we have here a triangle, right angle triangle, and this force for this triangle, for left side one 417 Newton, and right side one also 417 Newton. So we are taking only one, only one we are taking. So here opposite uh, this side is opposite, right? You know the way, right? If angle is this one, then opposite is this one for right angle triangle. Do you know this rule? So, hello,
Sir,
yes. Are you understanding what I'm saying? If you are
yes, sir.
considering this angle 20 degree, then your upper side it is adjacent and the opposite side is giving you what? Opposite,
Ah,
isn't
at
it?
this an opposite. Yes,
Yeah,
sir.
this is opposite. So you write sine theta. Sine theta will be
So
sine theta will be
opposite by hypotenuse.
yeah. Yes, very good. Hypotenuse. So your hypotenuse is T, opposite is 417, right? Isn't it?
Sir, yes, sir. Hypotenuse is T.
Yeah. And your opposite is 417, right? Just now we calculated. Have you understood how it is 417?
Yes, sir.
Yeah, just now we calculated. So you can do the working to get T now, right? So what is the value of T now?
Yes. So doing it.
Sine 20, right? Okay. What is the answer? Check. What is the answer coming?
So doing it, sir.
Do it, please. Do it.
Sir, 8.201 into 10 to the power minus 4. 202.
8. You got 8. How?
Sir, sine 20 divided by 417.
How sine 20 divided by 4, 770? Your 417 divided by sine 20. You see the
Oh,
rearranging?
yeah, sir. Sir, mistake over
Sir,
here.
1219.23.
Yeah, 1 to
So it's the
19.13, right?
yes, sir.
Newton. It's coming C, right?
Yes, sir.
Then 1.2
Yeah,
kilonewton.
1219.3.
1.2 kilonewton. So you got it, right?
Yes,
Yes,
sir.
sir.
Resultant force for this one 834. That means each of the side, like for this T we are having 417, and for this T also we are getting 417. Altogether it's making 834, right? Isn't it?
Yes, sir.
Yes, sir.
So it's done now. Our class time is almost up, and you please try. Huh? I don't know how much you tried. You should try it. Huh? You got this worksheet printed, Navid?
Yes, sir.
Yes, sir.
So day after tomorrow we have Tuesday class. I want you to try at least MCQ part, my dear. Huh? Is it clear?
Yes, sir.
We have only few MCQs now, so at least MCQ try. And if possible, you also try the structured questions. Okay? Is it clear?
Yes, sir.
So thank you so much. Huh? Allah Hafiz.
Welcome. Salaam.
Allah Hafiz.
Walaikum salam.